But
Hmm.
another interesting thing that I actually just thought about was like, if like, I mean, kind of a random thought, but it is very directly related to this. Let's say it's like 5 degrees outside, or 0 degrees Celsius, by the way, not for the Americans out there. That's really cold. So let's say it's 0 degrees, 5 degrees outside. Basically, it's cold, and you put a metal spoon outside, and you put a wooden block outside, right? Now, after let's say 20 minutes, you touch the metal spoon and you touch the metal block. And you touch the wooden block. Now, which one's gonna feel colder? Like
The
the metal
spoon.
spoon, right?
Yeah.
Obviously. But the temperature of the metal spoon and the wooden block are the same. And that is where people are like, wait, hold up. So if they have the same temperature, how can one be colder than the other? And this is an interesting fact about the properties of the system. So in this
Like
case,
thermal
the metal spoon.
conductivity.
Sorry?
You're talking about thermal conductivity?
Thermal conductivity, yeah. So the spoon is metal, while the wood is porous. Well, the wood is wood, but like the wood is porous, a porous material. What that means is there are like these small gaps, microscopic gaps. Obviously, you probably can't see it, but there are these microscopic gaps that when you put your finger on the block of wood, all the temperature from the wood does not directly go into your finger. Because when you put your finger on that piece of wood, there's a lot of air that you're also touching, right? Like there's a lot of just gaps, empty gaps, because as I said, the wood is porous, right? So there's a lot of empty gaps that you're also putting your finger on. So the wood is not able to directly give you all of the energy,
Well,
all
actually,
of
it
the
would be your
temperature.
finger losing energy.
Well, yeah, technically because heat it flows from heat. Yeah, sorry. That's actually more scientifically correct. I was just trying to provide a picture like how it's flowing. But yeah,
Hmm.
technically your finger, because it's hotter, it's the one that's releasing the energy to the wood. And again, because of the porous material of the wood, it's not going to all parts of the wood. Now, contrast that with the metal. The metal, on the other hand, is very, very rigid, and there's almost no air gaps or air holes in that material. So the moment you put your finger on that, every part of your finger is touching at least some part of metal. So all parts of your finger are giving away heat simultaneously, and you have the feeling that it is colder, even though in actuality they are the same temperature. And I think that's a
Wow.
pretty cool thermodynamic fact. It's a really weird
Fascinating.
light hitting my face right
It's
now.
okay.